Hello class, this is Mr. Goodman and this is lesson 4.3, the sine law. So I hope you noticed that in the last two lessons dealing with SOHCAHTOA that all our triangles were right angle triangles. And that's all fine and dandy, but what happens when you don't have a right angle triangle? Because in life, you don't always get the triangle you want. Well, here's how we deal with that. For most situations, this is called the sine law, and it can be represented with two different formulas, honestly. Like maybe some of you have been exposed to this before. I just use this. Yeah, you can use it for angles and you can use this for side lengths, but I use it for both. It works just as well, and to me this is easier, but either one, it's the exact same thing. First bit you need to know is that when you have a non-right angle triangle, you can label the vertices anything you want, A, B, C. Anytime you see a capital letter, it's the name of a proper angle. Whenever you see a lowercase letter, it's the name for a proper side, just like in this formula. Well, the side length opposite the angle is the equivalent, or are equivalent to, not equivalent, are related to each other. So this is angle A, and that's side length, lowercase a, and so on. Okay, that's the naming. Much easier than with SOHCAHTOA. It's very easy to name these things. So what we would do is we'd set up the formula and we'd put in the information that we've got. Well, that's angle A right there, and we know that because all three angles have to add up to 180. So that's something that you can figure out ahead of time, and that's one of the reasons why we did that in the 4.0 prerequisite skills. There's side length A, or sorry, angle A, 80 degrees. The opposite length is, well, I don't know what it is, but I know it's a lowercase a, so there it is. 60 degrees and 32, 60 degrees and 32. 4 degrees and our unknown that we want to find, and there it is. Now at this point, kind of pretend for just a second that what's here in blue hasn't been done yet. You have the formula in front of you, but it doesn't make sense to have two equal signs in really any equation. What we're doing is we're choosing two of the fractions, either these two or these two or these two, to cross multiply with each other. And what we want to have is one unknown and three knowns. So this is known, and this is known, and there's our unknown. So with that, we can cross multiply and solve for what the value of C is. I'm going to be using our calculator a little bit. Now, when you do that, C times sine 60 is just C times sine 60, and 32 times sine 40 is just that. I haven't even done the math yet. You might be tempted to turn sine 60 into a number, but don't do that. It's some number, and it's just a lot of wasted time and a lot of rounding. Instead, leave it as sine 60. And now when we want to isolate C, divide this by sine 60. There it is in blue. And what you do to one side, you have to do to the other. And what you're left with is C equals this. So 32 times sine 40, make sure it's in degree mode, and then divided by sine 60. And that gives us an answer of 23.75, let's call it 23.8, and that's the answer. So that's pretty much how you do this. The only variation to this, let's kind of flip this around, is we take a question that says find angle C. That says angle C, so that's the angle we're looking for. We take our known information, put it into the equation, two knowns, here's the other known, here's our unknown, these are the ones we're going to cross multiply. And when we do that, we're left with 50 sine C, 35 sine 60. We divide both sides by 50. So divide by 50, and what we do to one side, we do to the other. And what we're left with is sine C equals this. And I'm going to put that in the calculator, and what pops out is this. Important to round to 3 or 4 decimal places here, because that isn't an angle. That's a trig ratio. And what that means is you're going to use second function sine decimal 6062, and therefore you're going to get an answer of 37.3 degrees. So we're using the same process to find an angle as we do with SOHCAHTOA, except we're just coming at the trig ratio a different way. That's pretty much the lesson, how to solve for an unknown side length or an unknown angle. The only thing that sort of takes this a step further is what if you don't have A, B, and C? What if you have D, E, and F? Okay, well, it's pretty much the same thing. We can figure out from this question that our angle F is 75 degrees. We take our information, put it into the equation, and we're being asked here to solve the following triangles. All that means is it's saying find all the missing information. Well, you know what? I'm just going to find lowercase f here. That's what solve means when I see that in a question. When I do that, I see that I have an unknown here. And this is the unknown I want. So I can't cross multiply these two like I did in the other two questions. I'm going to cross multiply these two fractions. Which again, divide both sides by sine 62, and put this in your calculator, and that's what you'll get. Again, try your best to leave the sine 43, sine 62, leave them as they are. It'll make your life a lot easier, and you'll get more accurate answers. Other than that, this is another example. I'm not even going to dwell on it too much, of where you're being asked to find what angle y equals. And I could have found what angle z equals or side length here. I'm not sure, just kind of looking at this. It's just another example of a missing, in this case, angle. We put in our information, and in this case, I didn't even write out all three. Writing it out all three when you kind of know which one you need is again, a little bit of a waste of your time. So I just went straight to it, and I just dealt with two of the sides with their corresponding angles. And then I cross-multiplied, got my trig ratio, 4 decimal places, and then that's my angle. Angle y equals, and I always like it to be 30, to 1/10 of a degree. You could round to the nearest degree, but I like to round to the nearest 1/10 of a degree. Last bit here, and we're done the lesson, which is, here's another triangle. What if you have to find side length A? There it is. So let's take our information, put it into the sine law equation, and here's a problem. This is unknown, this is unknown, and this is unknown. Using sine law, this does not work. You're at a dead end. And if you're wondering, well, what do I do then? Don't worry. That's the next lesson. And in the next lesson, we'll be using cosine law to solve that. So that's it. Pretty simple lesson. Again, you've done this before. And generally, I find this is a crowd pleaser, this one. It's pretty easy. Some of the related work is going to come from, cleverly titled, Serious Sine Law Questions. So that's going to be the where the homework comes from. And today's special feature is another book. I hope you're not just sitting at home and doing math and then going on TikTok and becoming TikTok famous, because you know what? There's a world out there that you need to know about, and a life you're going to need to live. And here's an important thing. What do happy people know? By Dan Baker. I read this book years and years ago, but the question is, well, what is it that happy people know that keep them happy? Is it just that they have a better life? No. Terrible things happen to all people, and in fact, everyone around the world is suffering because of this pandemic in multiple ways. But some people will come out of it happier than others. Why is that? What is it that they do that allows them to be happy given almost the exact same circumstances, or worse? It's a great question, and if you read something like this, it'll give you some wisdom that'll last you the rest of your life. So again, I hope you are making use of your time. And if you haven't yet, don't feel bad about it. Today's the first day of the rest of your life, and it's time to start. I stole that quote from a movie called American Beauty in the year 2000, and yeah, I don't mind doing that. Okay, that's it. Hope that was helpful. Mr. Goodman, signing off.